Welcome to today's Explainer. We're going to look way past those flashing red lights and blaring sirens to uncover the absolute extreme engineering hidden inside a common fire truck. When you see one of these massive vehicles speeding down the street, you're not just looking at a truck, right? You are looking at a highly complex, mobile energy station that's specifically designed to battle some of the most destructive forces in nature. So let's dive right in and discover the brilliant mechanical secrets that keep these trucks from literally destroying themselves while they save thousands of lives every single day.
It's so easy to fall for our biggest misconception. Most of us look at a fire truck and think exactly what's on the screen here. It's just a huge water tank on wheels. We just kind of assume that the water inside that big red box is easily enough to put out a burning building. But when we're talking about the reality of a massive blaze, that ordinary assumption is completely shattered in the very first moments. Fire devours absolutely everything in its path, and the amount of water actually required to fight it is just staggering.
4,000 liters. That's what a standard fire truck holds. Now, that sounds like a ton, but when firefighters engage those powerful water cannons, that entire 4,000-liter tank is emptied into the void in just 3 to 4 minutes. Think about that for a second. In the middle of a terrifying inferno, this multi-ton machine transforms from a full water barrel into an empty shell almost instantly. And that is exactly why a fire truck isn't really designed to just carry water. It's designed to constantly hunt for and pump water from external sources, whether we're talking about a city hydrant, a river, or even a deep country well.
All right, let's jump straight into Section 1, the myth of the barrel on wheels.
So, to pull water from an external source, say a pond, engineers had to overcome a massive hurdle. And that is the fact that the main pump physically cannot move in visible air. If you just drop a hose into a pond and flip on the truck's massive main pump, literally nothing happens. Its blades are designed to push heavy liquid, not light, invisible air, so it's just going to spin uselessly. To fix this, they created a seriously brilliant mechanical workaround. Step 1. A small, hidden auxiliary pump turns on and aggressively sucks all the air out of the hoses, creating a complete vacuum. Then, Step 2, the natural atmospheric pressure surrounding the pond actually shoves the heavy water up the hose, totally defying gravity and pushes it right into the empty truck. Finally, in Step 3, once sensors detect that the water has arrived, the auxiliary pump shuts off and the main pump roars to life.
Now take a look at the heavy steel wire skeleton fused into the thick rubber walls of these intake pipes. If you actually tried to suck water out of a pond using the soft output hoses that you normally see firefighters carrying into buildings, absolute disaster strikes. Those soft hoses, which are made of synthetic threads and rubber, they're meant to inflate under outward pressure. Under a vacuum, atmospheric pressure would instantly crush them flat, totally blocking the water. That's exactly why the truck has to use these hard suction pipes for intake. That heavy metal spring basically fights off the intense vacuum, keeping the pipe perfectly round so water can flow up from even the deepest wells.
Moving right along to Section 2, the heart of the machine, pumps and hoses.
Okay, it is officially time to dismantle the whole bicycle pump myth. A lot of people kind of imagine a giant mechanical piston hidden inside the truck, slowly squeezing water out like an oversized bicycle pump. But honestly, if they used that old design, the water would barely reach the second floor, and the machine itself would just shatter under the strain. Instead, the true heart of the machine is the centrifugal pump. We're talking about a drum made of ultra-strong stainless steel. Inside, there's this wheel with curved blades spinning at thousands of revolutions per minute. Water enters the dead center of the spinning wheel and is violently hurled out to the edges. This creates a colossal centrifugal force that compresses the water and shoots it out with enough explosive pressure to blast right up to high-rise windows.
But you're probably wondering, where does the pump get all that crazy power? Well, the answer is the PTO, or power takeoff. See, when the truck arrives at a fire, the driver pulls a special lever. Heavy gears shift, and the wheels are completely disconnected from the engine. Now all the furious power of that massive diesel engine, we're talking hundreds of horsepower here, is sent straight down a steel shaft and right into the water pump. The truck securely roots itself to the ground while the engine revs at maximum capacity. It literally transforms the vehicle from a mode of transportation into a stationary, roaring energy plant.
Which brings us nicely to Section 3, Taming Extreme Physics.
With all this immense energy roaring through the truck, it generates some incredibly dangerous physical forces. Just look at the roof monitor, that massive steel water cannon mounted on top of the cab. It's throwing dozens of liters of water every single second. The physical recoil from that blast is so violent, it could easily rip the roof right off or even flip the multi-ton truck onto its side. No joke.
So to tame this wild force, engineers designed specially curved internal channels inside the cannon itself. These channels literally force opposing streams of water to crash into each other inside the metal, effectively canceling out their own violent energy. Whatever shock is left over gets safely transferred down a heavy steel frame, directly into the chassis and straight into the ground.
And you know what's really amazing? That roof monitor is incredibly versatile. With just the pull of a lever, the operator can instantly change the shape of the water. They can fire a solid water ram, which is a super dense column of water packing enough raw kinetic energy to act as a battering ram that can punch right through a solid brick wall. Or, if they need to, they can switch it to a wide droplet cloud. This fine mist instantly absorbs the surrounding heat, creating a protective thermal shield for the crew and keeping the extreme temperatures from melting the truck itself. But as we know, sometimes water just isn't enough. There's this deadly myth out there that you can fight a gasoline or oil fire with water. If you actually try that, the fuel simply floats right on top of the water and spreads the fire even further. Not good. So the truck relies on this awesome step-by-step foam system. Step 1, a clever little device called a foam mixer precisely injects just a few % of a chemical concentrate straight into the rushing water. Step 2, this mixture travels down the hose and hits the open air right at the nozzle. And step 3, it instantly expands into a dense, sticky, soapy blanket. This white foam physically covers the fuel, completely starves it of oxygen, and permanently locks the fire away.
Now picture this. You've got several crews all fighting a fire at once. The truck has a rear manifold, basically a distribution station that's sending water to the roof, the foam tank, and multiple handheld hoses. But what happens if a firefighter deep inside the building suddenly slams their hose valve shut? All that rushing, high-pressure water suddenly hits a brick wall. This creates what's called a water hammer, a violent, explosive shockwave that can literally blow apart the truck's steel pipes or violently rip the hoses right out of the hands of the other firefighters.
So, to solve this terrifying water hammer problem, engineers installed these mechanical bypass valves inside the manifold that acts kind of like smart scales. The very instant they detect that dangerous pressure spike from a closed hose, they spring open and instantly redirect that excess, violent energy safely back into the truck's main water tank in a continuous loop. Because of this brilliant piece of engineering, the other firefighters working on totally different hoses don't even feel a bump.
All right, let's look at Section 4. Hidden threats, cavitation, and overheating. So even if the water is flowing perfectly, the truck is still facing some invisible enemies while it just sits entirely stationary. The first one is cavitation. It's a really common myth that cold water can't hurt heavy stainless steel. But if the pressure inside the pump drops too low, this irreversible and honestly terrifying physics phenomenon kicks in. The ice-cold water literally starts to boil at room temperature, creating millions of microscopic vapor bubbles. And when these bubbles flow into a normal pressure zone, they don't just pop, they violently implode. These micro-implosions generate microscopic shockwaves that chew through the solid stainless steel blades like wild rats, tearing actual chunks out of the solid metal. Operators literally have to constantly monitor their pressure gauges just to prevent this catastrophic failure from eating their pump alive. Then there's the second hidden threat, overheating. Think about it. The truck's massive diesel engine is revving at its absolute limit, yet it's sitting completely still in suffocating smoke and heat. A normal truck's radiator would fail, and the engine would completely melt down in about 15 minutes. The incredible engineering hack here is a dual-circuit heat exchanger. Engineers routed extra steel tubes directly through the engine's cooling jacket, and they pump a small amount of the freezing pond water from the main pump right through it. So the very water they are using to fight the fire actually absorbs the extreme heat of the diesel engine before returning to the pump. It cools the beast from the inside out, letting it run flawlessly for days on end.
And finally, Section 5, smart electronics and perfect balance.
To tie this whole shebang together, modern trucks rely heavily on computer brains. I mean, gone are the days when a human operator had to frantically turn manual valves and try to guess the pressure. Today, the truck is protected by an invisible electronic shield. Imagine a heavy piece of burning debris falls and accidentally pinches a firefighter's hose. Without automation, the pump would just keep pushing and the hose would explode. But this electronic brain detects that dangerous pressure spike and drops the engine's RPM in literally 1/100th of a second. It instantly levels out the pressure, completely eliminating human error and protecting the crew during their most vulnerable moments.
And what about actually getting to the fire? There's this lingering myth that these trucks are top-heavy, wobbly barrels just waiting to tip over on a sharp turn. But in reality, engineers wage an absolute war for every single millimeter of space to create the perfect center of gravity. Notice how this aggressive weight distribution places the heaviest items. We're talking the steel pump, the massive water tank, and heavy hydraulic cutters on the absolute lowest shelves, hugging right against the chassis. The highest shelves, those are strictly reserved for lightweight gear like suits, masks, and medical kits. This setup creates such an incredibly low center of gravity that this multi-ton behemoth can take high-speed city corners safely.
Okay, so the fire is out. Job done, right? Not even close. The second the truck returns to the depot, this breathless maintenance checklist immediately begins. The crew has to instantly wash out the pump channels so the chemical foam doesn't dry up and ruin the internal valves. And those soft output hoses, they get hauled way up into a tall drying tower so they don't rot away. Fresh, perfectly dry hoses are loaded into the truck. The water tank gets topped off, the foam concentrate is completely refilled, and the diesel tank is brimmed. Within minutes, the Red Giant is perfectly reset, just sitting there in silence, waiting for the very next siren.
So, we've broken down the crazy vacuum physics, the raw centrifugal forces, the thermal shielding, and those lightning-fast computer brains. Which really leaves us with this final thought. The next time a fire truck speeds by you on the street, will you just see a simple water barrel on wheels, or will you see a multi-ton, mobile powerhouse of extreme physics constantly fighting to keep itself together while it saves our lives? Thanks for joining me on today's Explainer, and remember to always look beneath the surface.